Alrighty, this is lesson 4.3. This is our first day. Students are working on the warm-up problems of multiplying these polynomials and then finding the GCF. What's your question? No, you add powers.
I don't have the notes.
Just you? Alright. You finished the first two, try the next three. Finding the greatest common factor of the two numbers. We've got 1 more minute to try these. Okay. So, a polynomial refers to, the prefix poly means many, is when we have like many terms in an expression. So if I have like 2 terms in an expression, like the one in parentheses here, that's technically classified as a binomial, meaning 2. Okay, learn some of this vocab probably in Algebra 1. If I have 1 term, so technically like this 3x is being multiplied to the binomial, we call that a monomial. All right, so we would distribute here. Now, 3x times 3x squared, you do 3 times 3 is 9, and you add the powers and become x to the third. Okay, hopefully we're good with that. And then when I distribute the 3x to the negative 5, I do 3 times negative 5 is negative 15x. Okay, hopefully that one was pretty easy for us. It's a classic Algebra 1 problem. Number 2. So I have 2 times 2 binomials. X plus 5 times x plus minus 2. There's kind of a couple ways you could tackle this. Now I don't distribute the 2 to everything, because when you multiply 3 numbers just like in general, what your brain would probably do is like multiply 2 numbers first, like 3 times 7 is 21, and then multiply the 2. You don't distribute the 2 to the 3 and the 7, right? That's only if we have like a summary difference. So if you thought distributive property, that would not work in this case, but I have 3 factors being multiplied together. So you kind of pick 2 factors to multiply first. So I kind of multiplied these 2 together first, and then ended up multiplying everything by 2. You could also multiply like the 2 and the x plus 5 together first, and then multiply it to the x minus 2, but this is a good review of how we multiply something like this. Okay. You might have heard of the word FOIL. That's first, outer, inner, last. Okay. Really, I'm not a big fan of the word FOIL, but really you're just distributing. Okay, so ignore the 2 for a second. You got to distribute the x to the x, and that'd be x squared. The x to the negative 2, that'd be negative 2x. And then you also have to distribute the 5. All right, so 5 times x, 5x. 5 times negative 2 is negative 10. All right, before I distribute the 2, I see I have some like terms here I can add together. So I get x squared plus 3x minus 10. And then you can finish this up by multiplying everything by 2, or doubling everything in this case. we get 2x squared plus 6x minus 20. So again, a couple different ways, because obviously you can multiply in any order. So you could have done the 2 times the x plus 5 first, maybe you did the 2 times the x minus 2, and then multiplied the x plus 5 in, but we all should have gotten that product. Okay. So what we're going to do in this lesson is we're going to what we call factor, which is undoing multiplication, undoing the distributive property. So we're going to try to go from this answer to that factored form where we can see all the factors listed out. We're going to try to go from this product to this factor. Okay, so a lot of what we do is look for the greatest common factor. Okay, you're basically undoing multiplication. So let's just practice GCF. Do you remember what a factor is? It's a number that multiplies the numbers, so like the factors of 15 are 1 and 15, 3 and 5. So if I want to find the greatest common one, I got to think of all the factors of both numbers and the biggest one that goes into both numbers. All right, so 15 and 30, what do we think the GCF is? You can shout out. 15, right? 15 is the biggest factor of 15, and that goes into 30. So their GCF would be 15. Okay, what about 32 and 40? 8. Nice. All right, last one. A little tricky here. 61 and 13. 13 does not go into 61. 13 doesn't go into 61. 1 is technically the greatest factor they have in common. Nice. Good. Okay. So today we start our journey on factoring. And we're going to hit it a little bit harder than normal because you guys would have shut down in Algebra 1 when you learned factoring. And remember, that was that little pre-assessment I made you take because I'm trying to show that we'll improve our factoring by the end of Algebra 2, which we should. So we're going to hit it pretty hard. I'm essentially going to teach it how I taught my Algebra 1 students from square one. Okay. So everybody, take a look at the yellow chart. This I put in yellow because it's gold. This piece of paper is gold. It's going to help you in the process of factoring any expression. So the very first step, and we're going to fill this out like as we do this. So we're going to spend like the next 3 days like filling out this thing. We're not going to do it all today. We're just going to take it step by step, okay? The more familiar you are with factoring, if you're like, okay, I feel like a little confident that I factored before, the more familiar this is going to seem. Okay, let's... Oh! I think I might have pinned it up there already. If not, I think I see your name. Okay, the very first thing we're going to do in any polynomial, so regardless if it's a binomial, meaning there's 2 terms, trinomial, 3 terms, if there's 4 terms, we just call that polynomial. The very first thing you're going to do is factor out their GCF. Factor out their greatest common factor. Okay, so everybody write that in that first bubble. We're just going to practice that for a while. And it's not just going to be numbers. There's going to be letters thrown in. And we're just going to kind of practice this factoring pattern. Okay, it's fun. I always say factoring is one of my favorite F words in math. It's fun. So I'm going to walk you through a few examples. You can see here, 1, 2, and 4. Those are called binomials. There's 2 terms. Number 3 is a trinomial. Okay. So I always start with just like the coefficients, the actual numbers. And number 1, I have 9 and 15. And I ask myself, what's the greatest common factor of 9 and 15? 3, right? Okay, then I look at the variables. One of them has an x cubed and one of them has an x. So what's the greatest number that they both have in common?
3x.
They both don't have 3. Just 1x, right? The greatest that they both have. So just, you're saying 3x is the GCF. Sorry. I think I meant x cubed. 3x. 3x would be their GCF, okay? So when you're factoring, you're really undoing multiplication, you're really dividing. Now, I normally don't write out this step, but if you want to in the first example to see how we do this process, you can if this helps you. 3x is their GCF, so we're going to factor that out. And then we're going to divide out 3x from each term. So 9 divided by 3 would be 3. X cubed divided by x. Well, if you have 3 factors of x and you take out 1, you'd have 2 left. Okay. 15 divided by 3, I'd be left with negative 5. And if I factor out that entire x, I would not have a variable left there. And that is what we call that factored form. And if you notice, that was the one from the warm-up, right? I gave you this factored form. You found the product. Factoring is going backwards. I gave you this. You factored out their GCF, and we just read our final answer just like that. Okay. You're really just undoing the distributive property when you're factoring. The nice thing about factoring is you can always quick check your answer by just quick multiplying it through and see if you get back to your product, right? So you could in your head do, okay, 3x times 3x squared. Yep, that would give me 9x cubed. 3x times negative 5 would give me negative 15x. Okay, let's try another one. 14 and 21, what would be the GCF? 7. Yep. All right, how many x's can I factor out here? 2, right? They have 2 in common. I can factor out a 7x squared. So this is how I usually just show my work. 7x squared, and then I ask myself, okay, 14, if I divide out 7, I'm left with 2. I'm left with 1x here. Okay, again, you can do this if it helps you. And here I just left with a negative 3. Okay, that makes sense to everybody? You kind of already in this in Algebra 1 or not really?
Yeah.
Yeah. You don't do a whole lot of factoring in geometry, so you didn't get much practice of this last year, but Algebra 1, typically you spend a lot of your second semester factoring. All right, trinomial. Ooh, you got to find the GCF of 3 terms now. So looking at the numbers 3, 33, and 12, what's their GCF? 3. Okay, my variables here, I have n cubed, n squared, and 1n. So this one has a max of 1n, so I can only factor out 1n. 3n would be the GCF there. What's that? Oh, you want to read the answer? Okay, what'd you get?
I got 3n in parentheses and 2 minus 11 and plus 4.
Perfect. Okay, starting off basic. So if this feels pretty easy, that's good. That's a great first step into our factoring journey. All right, ooh, good one. 8 and 2, what's the GCF? 2. How many y's could I factor out? 1. All right, now, this one I am going to show my work here because this is important. So obviously if I factor a 2 out of the 8, I'd be left with 4. And 1 y out of the 3 y's, I'd be left with 2 y's. Now when I factor out an entire term, I'm not left with 0. Okay, because what's 2y divided by 2y? 1. Yeah, I'm left with a minus 1. A lot of people, when they factor out an entire term, they'll be like, oh, I took out that 2y, it's gone. And again, if you're not sure, quick distribute it and make sure you get back to your product. Okay? Oh, wow, look at all that practice I gave you guys. All right, you guys try the next 10.
Do you want them in like order to where the greatest exponent is first?
Yes. That should. Oh. No, you don't have to do that in this one.
Okay.
You can if you want to. That's a good question. This is step 1. We're always just going to factor out a GCF. So we're practicing. I'll give you about 1 more minute before I start putting up some answers for you to check. Okay. I'm going to quick let you check your answers on these. I'll kind of quick read through them. Number 1, 2y squared was the GCF. Number 2, 3x was the GCF. Number 3, 2 was the GCF. 4, 3x again. 5, only an s. Share that plus 1 left. 6, d squared would be the GCF there. Number 7, 7w squared. Number 8, 4a was the GCF. Number 9, only a 2 was common between those. And number 10, a 2y. All right, and then quick check to make sure you kind of have the correct factor left behind, as I like to sometimes say. Okay. Any questions? Give me a thumbs up if you feel good with that. Question?
How did you d squared numbers?
Well, first of all, 5 and 2, the only common factor they have is 1. All right, this one has 6 factors of b, and this one has 2. So what's the largest number that they both have?
6.
This one only has 2. What's the biggest number that they both have in common? That's what GCF, common. 2 of them, right? So I can factor out 2. So here I'd be left with just 4. And here I would just be left with no more d's, but a negative 2. Does that make sense?
Yeah.
Okay. Other questions, Kayla? Your homework, your first homework assignment on this is an Alex assignment, and a lot of it is just factoring out the GCF like this. Okay, practice with this. Okay, back to the flow chart for a second. The piece of gold. After you do that, after you factor out the GCF, you're going to ask yourself this question. How many terms are left? Because that's going to determine our next strategy. There will be 3 possible number of terms. You could have 2 terms. We're actually going to do that last. 2 terms I think are not the hardest, but just the weirdest ones. There could be 3 terms. We call those trinomials. Or there could be 4 terms. And we're going to start with 4 terms. Okay? We're going to do something that is called factor by grouping. Factor by grouping when there's 4 terms. Okay. So here's like a quick example of factor by grouping. And it's going to look a little weird because I'm going to throw in an expression with 4 terms with a bunch of letters. So let's say I have ax squared plus ax plus bx plus b. No numbers. Algebra. Okay, so first I'd say, is there anything common I could factor out right away? These don't have a. No, there's nothing I could factor out. There's no GCF. I mean 1, right? So then I ask myself, how many terms do I have? I have 4 terms. So factor by grouping, what this is, and this might feel familiar from Algebra 1. You split it in half, and you almost treat it as like 2 separate terms. So I group them like this. The first 2, I group like this, and the second 2, and you're just going to factor out the GCF of each group. Okay? So looking at my first group of ax squared and ax, what do they have in common? Ax, right? Ax. So we're kind of essentially ignoring this second group. I could factor out an ax. All right? Here I would be left with x. And if I factor out this whole ax, I have to leave behind a plus 1. Okay, that makes sense? You can't scroll up, otherwise my ankle will not see. Now my second group, I ignore the first 2 terms. What can I factor out of the second group? You can shout out. B, right? A positive b. So write plus b. All right, if I did that, I would be left with x in the first term. And if I factored out the whole b, I got to leave behind a plus 1. With the factoring by grouping method, these two, what's kind of like left behind in the parentheses, these two should always be the same. Okay, if they're not, you did something wrong. All right, these two should always be the same. Now I technically have two terms, guys. I have ax times x plus 1. That's one term. I know it's kind of weird to see. And I have b times x plus 1. What do those two terms have in common? X plus 1, right? They both have x plus 1. So what we're going to do is we're going to factor that out. We're going to factor out the one that matches. The x plus 1. And if I divided that out from each of these terms, I'd be left with these GCFs, ax plus b. All right, so think of this as like a number. Think you got ax times 2 and b times 2. You're just factoring out the 2, and then you're dividing it out, and you'd be left with whatever those GCFs is. That's how you factor 4 terms. Does that feel familiar?
Yeah.
Oh, good. Other people? No. Okay, let's practice that. Factor by grouping. I'm on the next page now in the notes. All right, number 1. First thing I ask myself, is there anything common between these 4 terms that I can factor out right away? Besides 1. 12 doesn't have an x. So no, right? The numbers 2, 8, 3, and 12, their only GCF is 1, and I can't factor out an x. Then I ask myself, how many terms do I have left? 4. What's my method for 4? Factor by grouping. Split it in half. Group the first 2 terms, group the second 2 terms. All right, here I see 2x cubed minus 8x squared. Okay, can I definitely factor out a 2. How many x's could I factor out? 2, yep. And that would leave me with x minus 4. All right, in my second group, what's the only thing I can factor out? 3. Now, get in the habit of, if you're going to factor out a positive, because sometimes it might be a negative, if you're going to factor out a positive 3, write plus 3. Okay, and that'll also help you in the next step, group together your factors. All right, team, are these 2 factors the same? Good, we did a good job then. We're going to factor that out. We're going to factor out x minus 4. And if I divided out x minus 4 from each term, I'd be left with 2x squared plus 3. And that would be how that factors. How can I check my answer? Multiply it out. Okay, if you're really ambitious, multiply this out. 2, 2, 2, 2. You'll get back to that product. All right, let's try another one. Number 2, anything common I can factor out right away. That's always my first step. No. Okay, some x's, some y's here. How many terms do I have? 4. So split it in half. Factor by grouping. Oh, got x's and y's here. Have no fear. So I have 3 and negative 1, so there's no number I can factor out. I have 1 x and 2 factors of x here, so the greatest they have is just 1 factor of x. Then I have a factor of y in both, so xy would be what I could factor out of those first 2. That'd be their GCF. So that would leave me with, and again, if it helps you guys to write this to see like what you're left with, because you're just dividing it out, you're left with 3 minus x. Okay. Now here's the part where you'll probably never hear me say this, but I kind of let students cheat a little bit. It's kind of a little more working backwards. We know we want these to match, right? We know if we're left with 3 minus x, we want 3 minus x. So sometimes if you can't quite figure out how to get those parentheses to match, work backwards and say, all right, what would I need to factor out here to be left with 3 minus x? Does anyone see what number could possibly, what'd you say?
Negative.
A negative 2. Okay, let's see if Riley's thinking here works. Do you guys agree that negative 2 times 3 would give me negative 6? Yeah. And negative 2 times negative x is 2x? Yeah. Now, what sometimes students will do, don't write this down, just look up here for a second. They'll see this and be like, oh, my GCF is 2, which is fine, but then you need to recognize, uh-oh, those are not the same thing. 3 minus x is not the same as negative 3 plus x. All right, so that might be a little hint at you. You're like, I have the same terms with different signs. Maybe I should try factoring out a -2. And that would indeed leave me with 3 minus x, because again, you're just dividing out that -2. Okay? Or like I said, we know these are supposed to match, so you can kind of work backwards if you need to. Cheat ahead a little bit. Say, I know this is what I need. What would my GCF be in order to get me left with the 3 minus x? All right, so let me factor out the 3 minus x. What would my second factor be? Xy minus 2. Yep, exactly. Xy minus 2. The GCFs put together. All right, folks. Everybody try the first 2, and then we'll check in.
Can you move stuff around or no?
No. I mean, technically yes, but in this case you don't want to. Everybody try the first 2 and then see if you can find it. Second one's maybe a little tricky, so you can figure it out. You actually don't want to add together the 7 and the 10. We want to keep it as 4 terms. You could do it that way ideally, but we're practicing the factor. Nice. Good job. You're doing well. Okay, you got 1 more minute. If you feel comfortable with the first 2, you can try number 3. Number 3 is probably actually a bit easier. All right. So most of us got this one. So out of our first group, we should have factored on x squared. You'd be left with 2x minus 3. And in order to be left with 2x minus 3 out of my second group, you should have factored out a -2. All right, so then you factor out the 2x minus 3's. And you'd be left with x squared minus 2. Okay. Now I saw Connor add these together, which actually you can do that algebraically, right? Those are like terms we could. We're practicing factor by grouping, so don't do that for this case. Split this in half. All I could have factored out of my first term was an x. And I was left with 10x minus 7. And then I look at my second group, I'm like, that looks so close to 10x minus 7, but it's negative 10x plus 7. So did anyone recognize what we'd have to factor out there? -1. Yup. So you recognize that too, right? I did. Good job. A -1. And again, get in the habit of actually writing a -1 in front, because then when you go to write your two sets of factors, you know, obviously one factor is at 10x minus 7. The other factor would then be x minus 1. Okay, good. All right, try 3 and 4. These ones I think are a little bit easier, so I'm going to give you a little less time. If you feel ambitious, you can try 5. 5 is a little more difficult. Okay, this one is actually something you can factor out first. Yeah, that's how that should be. I didn't check the rest. Did you do number 6? Okay, I'm going to start writing the answer for 3. You can check this one quick. All right, there's the answer for 3. Now, don't forget, folks, you should still be doing that first step of checking if you can factor out something right away. Okay, right now we're kind of zoned in on just practicing how to factor 4 terms, but you still should be asking yourself, hey, is there anything common I can factor out right away? We haven't hit that until we get to number 5. Okay, so even though I haven't been like verbally going through that thinking process, that's still technically our first step. Can I factor out anything right away? No. How many terms are left? 4. All right, factor by grouping. So number 4, you can factor out an a squared to be left with a plus 13. And again, if this helps you, work backwards and ask yourself, what could I factor out of that second group in order to be left with an a plus 13 and be a -5? Then you can factor out the a plus 13s. And you're left with a squared minus 5. Okay, let's maybe do number 5 together. If you want to try it, if you want to like work ahead of me, you can. 5 is tricky for 2 reasons. 1, we have that first step of we can factor out something right away. And 2, there's 3 variables here, a, y, and b. Okay, that's okay. It still works the same way. And that flow chart of going through the steps, what can I factor out right away? How many terms will work no matter what the number of variables or letters you have. All right, does anyone see what we could factor out right away? A 2. All these numbers are even, right? 18, 24, 48, and 64. So you might even be checking like, okay, this 4, 4 doesn't go into 18. 6, 6 doesn't go into 64. You should be checking like the greatest, right? But 2 is the biggest that factor of all these terms. So if I take a 2 out, I'm left with 9a minus 12ay plus 24b minus 32by. And then you can kind of look at what your terms are left with. You're like, okay, yep, 9, 12, 24, and 32, they don't have any more common factors, right? So we know choose their GCF. So don't forget about that first step still. Then you ask yourself, how many terms are left? 4. So what do? Factor by grouping. What can I factor out of this first group, folks? You can just shout it out. 3a, good. 3a. So I would be left with 3 minus 4y. Now I still have this 2 out here. Don't forget about that. I still have this 2 out here. It doesn't, you can't just divide it off. This is an expression. Okay. What could I factor out of my second group? and think. We want to be left with 3 minus 4y. So automatically I'm thinking, all right, I'm going to want to factor out an 8b. 8b times 3, that would give me 24b. 8b times negative 4y, that would give me negative 32by, right? That would work. Okay. So this factor is in the middle here. In my inside, I have 3 minus 4y times 3a plus 8b. And then I still have this 2, and you can just leave the 2 out like that.
If we don't factor out the 2, is our answer still correct technically or not?
No, that's not fully factored then. If you didn't factor out a 2, you might be left with like 6 minus 8y, and that's not fully factored. Or you might be left with 6a plus
Yeah, that's what I am.
16b.
Yeah,
Yep,
that's what I got.
that's not fully factored. If you got there though, and you recognize, oh, hey, I could factor a 2 out, just bring the 2 out. Yep. But you will never have to worry about that if you follow the steps of factor out the GCF right away. All right, you guys finish up this last one. Really quick.
Does it matter the order, like the...
Oh, the factors?
Yeah.
Nope. You can multiply in any order, so it doesn't matter. Good question. All right, there's nothing we can factor out right away. So we'd have to factor by grouping here. 5x out of the first group, 2x minus 3. And you're like, this is already 2x minus 3. So what would I technically factor out? Positive 1. Good. The annoying thing about these problems is they just take practice. As you can tell, we just did like 30 of these problems, right? Think of it as like a factory boot camp. It's just drill. Skill and drill. All right. The only other thing I want to show you, so there's some like that to practice on your ALEKS assignment too. Let's go back to our flow charts. I might just show you 1 or 2 examples if we have time. If not, it's okay. What we're going to tackle tomorrow is if we have 3 terms left. And if there's 3 terms left, it kind of depends on the setup. All right? So on this bubble, I want you to write this. 1x squared and underline the 1. 1x squared plus bx plus c. If there's a 1 in front of the x squared, the only way this can factor is from 2 binomials of x times x. Okay, we did one of like this in the warm-up, and we'll look at obviously more examples. But the only way we can multiply to x squared is x times x, right? So what you're going to do to figure out these 2 numbers is going to do basically like that worksheet I gave you. You're going to practice thinking what multiplies to c, meaning your constant term, and adds to b, which is this one. What 2 numbers multiply c, add to b? Okay. Write that in your notes for now. I'm just going to show you one quick example. That way, if you want to try the ALEKS on your own, you can. Because the ALEKS assignment is just factoring out GCF, factoring by grouping, in these cases. And there's a 1 in front. Okay. So under example 3, look at this first problem. We're just going to do this one. Back in the notes. Anything I can factor out right away of those 3 terms? No. So how many terms do I have? 3. There's a 1 in front. So this is going to factor into x times x. All right. So my c is 6. So you got to ask yourself, what 2 numbers and this is how I kind of show my work. Multiply to 6 and add to negative 5. What 2 numbers multiply to 6 and add to negative 5? Negative 2 and negative 3. Okay, so this is kind of like the little arrow. Those multiply to 6 and they add to 5, negative 5, right? So this factors into x minus 2 times x minus 3. Now I'm just going to quick show you why this works. I'm going to multiply it out. You don't have to do this in your notes. But x times x would give me x squared. And that's what I'm saying. If there's a 1 here, the only way you can get to x squared is x times x. Minus 3x minus 2x plus 6. And then you have those two that add to negative 5x. And we get that product. Okay.
So the homework's the Alex assignment then?
Yeah, the homework, I mean, it's not technically due till Friday. Hold on, let me pause the video quick. So if you look on your chapter outline, there's actually 3 assignments that go with this lesson.